first, let's take a look at your the experimental method for determining what we call heats of reaction, the amount of energy given off for a particular chemical reaction, the thermochemistry. All right, so you did take a look at in some format at a calorimeter type of experiment, either using the Pogel or actually doing it. So I just want to go over it briefly with you again, because it's a real important basic little experiment that can be done to give that type of heat energy information about a chemical change. Okay, so all right, so this is called a calorimeter. First of all, let's just look at this device. This particular device, it might be different. If you did one in your in lab, a lot of times what people do is use a coffee cup calorimeter, which is just really a styrofoam cup with a lid on it and a little hole at the top for a thermometer to go down in. Okay, and then you put water in it, and then you start off at room temperature or whatever, and you put in some reactants for an aqueous chemical reaction. It's something that's going to be reacting in water, and so you just look at the change in temperature of the water. Okay, this is a coffee cup calorimeter type of deal. All right, and so in this case, the way you calculate the amount of heat or the heat of reaction using a coffee cup calorimeter is that you would throw the reaction in there and you would just monitor the change in temperature of the water. So you would check the temperature before you start, and that would be your initial temperature, and then you would check the temperature when you're finished, and that would be the final temperature. So say you start off at like 23 degrees Celsius or something, and you end up at 40 degrees Celsius when you're finished. Then you would, from those two numbers, you would get the change in temperature, which is always the final temperature minus the initial temperature. And in that case, in this case, it would be a 17 degrees temperature change. All right, and based on the change in temperature, then you could calculate the amount of heat that was given off on whatever chemical reaction you were running in there, because what you learned from the Pogel exercise is that water and every substance has something called a heat capacity, and the heat capacity is the amount of heat energy that's absorbed per gram of substance, and it's related to the change in temperature. Okay, it's the amount of heat absorbed for 1 degree temperature change for 1 gram. All right, and so that's called the heat capacity. So we know the heat capacity of water, and which is 1 calorie per gram per degree Celsius. That's the definition of a calorie, as a matter of fact. And so the heat given off by that particular chemical change would just be Q. Q, remember, is our symbol for heat. Heat equals the specific heat of water times the mass in grams of water times the change in temperature. Okay, and so that's how you calculate it for that. In the case of this type of calorimeter, this is called a bomb calorimeter. This is the type of calorimeter we would use, for example, if we were trying to figure out the heat of reaction, the amount of heat energy given off per gram or per mole of methane, because methane is a gas, and you can't put gas, you can't put the methane in water and expect it to burn in water. So you'd have to have this type of a thing, which is really called a bomb calorimeter. And so what you have is a larger container that's filled with water, and a stir bar to make sure that the water stays mixed up good to keep the temperature the same throughout. And you got a place for a thermometer that's immersed in the water, and then you have this little reaction device, which is sometimes called the bomb. The reaction chamber is called the bomb. And so let's just pretend like this is methane. Stick some methane in there, and then you put a little fuse wire in contact with the methane. Would really be a gas, but to add a little spark, because the fuels don't start burning unless you give them a little spark to get over the reaction barrier. And so anyway, you put a little spark in there and you let the reaction run, and heat energy is given off in all directions. So this little bomb is going to heat up, but it's in thermal contact with the water, and the water is going to heat up. So the temperature of the water is going to be the same as the temperature of the bomb. And in this case, when you're trying to figure out how much heat energy is given off by a certain amount of fuel, it would be the heat energy is going to be equal to the total mass of the water that's surrounding this whole big thing times the change in temperature of the water times the heat capacity of water, plus the change in the heat that's absorbed by this little bomb thing. And normally the bomb thing itself will be calibrated, and it will have what's called a calorimeter constant, and it will account for all the different materials that are in this device. So rather than the heat capacity of the device, it's called the calorimeter constant, and that's just C times change in temperature. Okay, and within this constant is the mass of the whole thing, and the heat capacity of it. So it'd just be C. This C is the calorimeter constant. Okay, so it's the same concept as your simple coffee cup calorimeter, only sometimes there's two parts. And then finally a third, and it's all the same concept, but sometimes with these types of calorimeters, the whole thing is calibrated. The amount of water and the bomb and everything is just calibrated into one calorimeter constant, and in that case the equation would be just Q equals change in temperature times the C in this case is the calorimeter constant, which takes into effect all parts of the calorimeter. Okay, it's all the same concept though. All you're doing is monitoring the change in temperature while the reaction is occurring, and understanding the concept of heat capacity. You can then calculate how much heat the heat that's absorbed by the surroundings, which could be the water and the bomb thing, or just the water in this case, or the water and the bomb thing combined into one constant anyway, but the heat absorbed by the surroundings, however you define them, is going to be equal to the heat given off by the chemical reaction, and in that way you can determine the heat of reaction for the reaction. So you should have done that in a lab or in the POGO, but I just wanted to go over it with you briefly before we go on. And so I'll give you a couple homework problems to practice with that, and you should probably practice them in small groups. Since I didn't do any examples here, you would have done it in your POGO exercise. The big idea then behind all of this is the experimental way of determining the amount of heat that's given off by a certain chemical reaction. Now, if the temperature goes down across the chemical change, then that would tell you that much heat is being absorbed from the surroundings. So in that case, it would be heat is actually energy is being absorbed by the reaction. Okay, so heat can be given off or absorbed.